Have you ever thought about what the most favorite Halloween candy is? In this study, we take more than 200,000 survey responses to that question and more than 90 pieces of candy or different types of candy and analyze which ones are the most favorite. We then gather more than 10 characteristics of candy and analyze the results of winning and the features of the candy and see what the most important features are. Some of the features are the price, the sugar percent, whether or not it has caramel or nougat or chocolate, or perhaps if it's in a bar form or if it's in a different form. In the end, we will go through our SQL and our Python analysis, and then we will show you what the most favorite candy was and what characteristics it has. Sounds fun, huh? Welcome to this presentation where we are going to take survey data from many respondents and try to answer the question, which Halloween candy is best? The decision problem here is that a store wants to capitalize on the popularity of Halloween candy and wants to sell the most candy of all its competitors. The store wants to make sure to have vast quantities of the most popular candies. The question the store wants to know is, what's the most popular Halloween candy? So a survey would be useful in determining which is the most popular. The data was collected for this study by creating a website where participants were shown two fun-sized candies and asked to click on the one they would prefer to receive. In total, more than 269,000 votes were collected from more than 8,000 different IP addresses. While this study was not scientifically rigorous, it is a large data set with a wide variety of respondents from numerous different people. The first thing that happens in this study is to design a survey instrument and to execute it, and in this case it was executed with a web page survey. After the survey is administered, data is collected, and in this case, we would import it into an SQL database, and we would record each winning percentage of candies, and then we would look to identify characteristics of the candy to gain further insight as to what characteristics lead people to like one candy versus another. So here is a list of the characteristics of candy that we are going to gather data on. And the first ones here are either yes or no, meaning it either has this characteristic or it doesn't. So whether or not it's chocolate, whether or not it is fruity, caramel, whether or not it has peanuts or almonds in it, whether or not it has nougat, whether or not it has a crisp rice wafer, whether or not it is a hard candy, whether or not it is a bar. Pluribus means whether or not the candy comes in a package with many different pieces of candy. Then the percentage of sugar in the candy and the price percent. The other two attributes then are the competitor name and the win percent. The competitor name is the name of the candy, and the winning percent is what percent of the time did a candy win against all of its competitors. So here is what our data looks like after we've done some pre-analysis and some setup and structure so that we can do our main advanced analysis. So this first column, we have the competitor's name, for example, the 100 Grand Bar, a Three Musketeers, an Almond Joy, or a Baby Ruth. And then we have a 1 or a 0. So a 1 here in the chocolate column means that it does have chocolate. A 0 means that it does not have chocolate. And then we have fruity, caramel, peanutty almond, nougat, crisp rice wafer, hard, yes or no whether it's a bar, yes or no whether it's multiple candies in a package. The sugar percent, and that's a percentile, so for instance, if it's 73% here, it's in the 73rd percentile as far as sugar content. Then the same is true with price percent, so it's what percentile of the price. So for example, the 100 grand bar is at the 86th percentile in terms of price. And then we have the winning percent. So again, for example, the 100 grand bar won 66.9% of the time. Once we have the data set up, as we showed in the previous slide, then we can proceed to analyze it, hopefully in a very in-depth way. Now, we could analyze data in something as simple as Excel, or perhaps Python, R, SAS, or SPSS. We decided to use Python because it is used extensively in industry, and it has nearly unlimited numbers of libraries for specialized purposes. Once we are in Python, the first thing we want to do is import libraries, and I normally do that in this first window. Importing pandas and numpy is very common for nearly all data analytical tasks. You see the rest of the libraries that we've imported, including an operating system, request, Chardé, matplotlib. That one is very common as well. Seaborn is very common, and we are going to import stats model to do some advanced statistical analysis. Once we've done that, we read the data from a data file into a data frame. So here it is. My file is called candydata.csv, and I've read it into a data frame, and that's data df_candy. I list it right here in this number 3, so this df_candy is just like printing it. And so now you can see the data from the data frame being listed here in Python. We have the data in the data frame, and in this instance we are going to rotate it. Remember in the previous slide that these candy bar names that are now column titles, they were in the first column and they were each a value. So T stands for transform, and it's the same as rotating the data frame on a specific column's values. Here we take the non-rotated or original data and we look at a random sample of 5 rows. Here we see the candy or competitor being Ring Pop, Super Bubble, Mounds, and Werther's Original Caramel. So the dot sample and taking 5 allows us to grab 5 randomly generated rows. Suppose we want to see how many columns are in our data set, what the data types are, and how many rows we have in the data set. We use the DotInfo method, and we see the column, for instance, chocolate or not. We have 85 rows of data, and we have the data type here, whether it's character, like the name of a piece of candy, perhaps like a Hershey bar, and then we have the integer, that should be a 0 or a 1, and then we have float here for sugar percent, price percent, win percent, so that we can make calculations from those columns. An easy way to look at some basic statistics on any data set is to use the describe method. So we take our data frame, do a .describe, and we can see how many rows we have, what the mean of each row is, standard deviation, the minimum, the 25th percentile, the 50th percentile, the 75th percentile, and the largest. Now these aren't as interesting because they're either zeros or ones for the chocolate or fruity or caramel, but they do have a lot of meaning when we look at the win percent and the sugar percent. One great thing about Python is once you have your data in a data frame, it's easy to make a wide variety of charts. Here we're going to make some plot charts, and this first number 9 window is we're going to count the number of features or the observation in each categorical bin. And we're using the Seaborn library to do a plot chart, and here is each of our features. We have chocolate, fruity, caramel, peanutty, almond, nougat, crisped rice wafer, bar, pluribus, and hard. So we're going to see a plot chart for every one of those features. Here are a couple of the plots that were created in the previous slide. Let's look at this one, and it says fruity right here. The blue represents the candy that did not have fruit, so that's a 0, and the orange here is a 1. So we see that for the fruity category, somewhat above 45 is the number that do not have fruit, whereas something above 35 but below 40 is the number of pieces of the candy that we did that do have fruit. You can see we have something similar here with caramel, something similar here with chocolate. So that one slide where we declared each of those categorical variables creates its own box plot, which seems very efficient to do that many charts with such little code. Here is another Seaborn box plot. This time we are going to look at the category of chocolate. 0 means that we have no chocolate, and a 1 means the candy does have chocolate. Here on the y-axis we look at sugar percent, and we'll see that there's quite a bit more variation in the sugar percent in non-chocolate than we see in the sugar percent with chocolate. So it's fun to see these box plots and see where a majority of the data falls. Here we are going to define our x-axis, our independent variables, and each of those are Boolean, meaning they're 0 or 1. As we've mentioned a few times, those include chocolate, fruity, caramel, and so on. Our y, or our dependent variable, is winning percent. Let's list that out and see what our Boolean feature list is here, and indeed it's the list that we've come to know. Here we look at the distribution of winning percentage on the data set. Remember just for a moment that each candy has a win percent. For example, Three Musketeers wins 67% of the time, whereas Boston Baked Beans wins 23% of the time. So in the distribution here, we see that a great majority of our data is somewhere between 30 and just short of 80%. Not very often does something win more than 80%. That's probably our number 1 candy. This is the Python code that is going to let us build a bar plot chart to see the winners and the losers. We will define the 5 candies that performed best and the 5 candies that had the lowest winning percentage. Here then is the bar plot that we just defined, and it is going to show the 5 candies that won most often and the 5 candies that won least often. So we see in blue the ones that win more of the time, and that's Reese's Peanut Butter Cup and miniatures. Down here at the bottom we have Chiclets, Boston Baked Beans, and Nick L. Nips. One of the things that people love to do when they examine data is to look at correlations between features. In this example, we are going to correlate features such as chocolate and see how often that it appears with something like caramel or fruity. A way to do that is to make a correlation matrix, and in fact in this slide here we see how to make a correlation matrix. Here then is the correlation matrix that is generated from the code in the previous slide. Here on the left side we see chocolate, fruity, caramel, peanutty, almondy. Again, here down on the bottom on the x-axis is chocolate, fruity, caramel, peanutty, almondy. It's interesting to note that a feature correlated to itself is always 1, so we see that on the diagonal, and chocolate here is correlated with fruity at negative 0.74. So with regards to the candy that is in our data set, we infrequently see both chocolate and fruity in the same piece of candy. Here are some of our observations from the correlation matrix. The percentage of 1 matchups seems to be mainly affected by the presence of chocolate. Price impact is about the same as all the remaining categories except chocolate. Fruit flavored most of the time means no chocolate. Sugar content is very well balanced among all categories except price, which means cheaper candies also have lower sugar levels. Chocolate is sold at significantly higher prices than average, whereas fruit-flavored candies are sold at lower prices. Chocolate frequently comes in a bar-shaped candy, also with peanut almond, crisp texture, and nougat or caramel. Fruit-flavored candies have almost no overlap with chocolate in terms of other categories, which frequently indeed misses those categories. Here is how we do an ordinary least squares regression in Python. Notice here that we see the Python code that lets us do that. Our dependent variable is going to be winning percent, and our coefficients include chocolate, fruity, caramel, peanutty, almond, nougat, crisp rice wafer, hard, a bar, pluribus, sugar percent, and price percent. Just to review, ordinary least squares regression helps us look at a dependent variable and see its variation to the linear model. In fact, R squared is that percentage. Some of our findings are, with the baseline configuration, the adjusted R square is 47.1%. Some of the features are clearly unable to help us explain any of the variation of the winning percent or dependent variable. For example, caramel, nougat, a bar, or multiple candies pluribus have p-values above 50%. Next, chocolate clearly appears to be the most important factor with a coefficient of about 20 on the percent and a standard error of 3.9. Fruity, peanut almond, crisp rice wafer, hard, and sugar percent also seemed to be important. In conclusion and to review, this study looked at which candy is most preferable by conducting a survey on a website. More than 270,000 responses were recorded, and though it was non-scientific, there was many different IP addresses that were recorded, so it was determined that many different people participated. Several features were recorded, which were then examined against the winning percentage. In the end, chocolate was the most important factor in determining a winning percentage. So, what was the winning candy? Something with chocolate and peanut butter in it, which turns out to be usually Reese's or some derivation of Reese's.